Who wasn't? Alright, there are some people that weren't. Yeah, okay.
I think we started this one yesterday, didn't we?
I don't think we started.
No mistake. Yeah. Oh, I'll take it. Do I need to take the pass or
No,
just go?
just don't act suspicious.
Okay.
Oh yeah.
Are you serious?
I'm using blue today.
I mean, I thought you misplaced your phone. Yeah. Very fine.
Where was it? Under my calculator.
Yeah! Okay.
I leaned you almost.
So we're going to do from the calculus review sheet number 5. For each of the following curves, find the gradient at the point where the curve crosses the y-axis, meaning derive it and then plug in 0 for x and then
Cry.
solve it. No crying because we're not setting it equal to 0, we're plugging in 0, so that's easier. Hopefully some stuff is going to cancel out. Alright, so there's just two different curves here. We're going to do this one first because why not?
What does 2 want from us? Part 2.
What does part 2 want from you?
Literally all it gives us is an equation equal to 8. Are we supposed to solve for y?
It
That's,
says find the gradient at the point
that's that
where
thing.
the curve crosses the y-axis.
Remember how we derive?
We're doing the same thing for
The
both.
thing that
We have to do for both.
what's the thing
okay.
with the x and the y where you derive where it's not equal to y? Remember that? That's a thing.
No.
Yes.
Remember? And then when you derive an x, it's just normal. And then whenever you derive the y, you do it just like an x, but then you have to write dy dx, and then you have to move it all over and get dy dx on one side. Remember that? That thing.
Really annoying.
What's that called?
I forgot. That's like it's called something weird.
It's probably should just.
Hold on, I don't like math.
It's
Remember we made a joke.
I.
Implicit.
Yeah.
Implicit, because then we made the joke, what about explicit differentiation? That's what it was. It was implicit differentiation.
Yeah.
Okay, cool. Well, then this is a really good one to practice then.
Alright.
Yeah, we have the usual one, which is explicit, and then implicit is the different one.
All right then. Cool. So we'll do this.
I remember that.
Yeah, right? Weird. So, I'm gonna go with, this would be quotient rule.
Yeah, I would say so.
Definitely.
Isn't it just,
Yeah, I think so.
yeah.
Alright, so that's low D high minus high D low over low low.
Yes.
Low D high minus high D low. So low, really gonna give out on me? Okay. Low, D high, so that's 2x.
Which one are we doing?
It's
Number
number 5
On the back of the first page.
on the back of the first
Okay.
Thank
page.
you. Minus 5.
Minus low D high minus
High D low.
high
And then E over D, or D,
D
over
low over, or
That's
low squared. Derivative of this is,
2e? Or is it negative e or
I
something?
think it's 2e to the 2x, right? Because with an e, you take this, take the derivative of this, put it on the front, and then leave e as it is, I believe.
Yes.
That's how you do that.
Yeah.
So it's just 2e 2x, right?
Yeah.
Okay. So 2e, because the 1 goes away.
Yeah.
So is that over lower quantity squared? Okay.
Yep.
So it's that, and then we just clean that up. Well, actually, could we just plug in 0 at this point?
Yeah.
I think we can just do that. I don't think we have to clean it.
I don't feel like it's a good idea for us to clean it because we'll probably mess it up.
Which is great because look where the x's are.
Yeah.
Exponents of the e, which means it's going to cancel
Zero,
become
it's gonna be
1,
one.
and then there's just a
One
few
minus
regular
one.
x's there. Alright, so
1 plus E.
that ends up being 1 plus, this becomes a 1, right? 1 plus 1 times 2 times 0. So that's
Minus.
not a, so that's
Minus 0.
that's
because-
gone.
Wait, no.
Minus 1
Yeah,
because
minus 1.
0 squared plus 1 times, once again, 1. And then over, oh, this is hard math. 1 plus 1 once again,
Wait.
quantity squared.
Is
So
that 2e to the 2x? Is that 1 though? Because
it becomes 1 because you put a 0 in for x, so it's e to the 0, and anything to the 0 is 1.
2e to the 2x would be 1 times 2.
So it'd be 2, wouldn't it?
It would be 2.
it would be 2 because
Because
of the 2.
the derivative 2e to the 2x on the top.
Oh,
2e to the 2x on the top. It would be
Oh.
2 because it'd be 1 times 2.
because it's 1 times 2, yeah, okay. Thank you.
And it's 1
then
plus.
it'd be-
Oh, wait, yeah. No.
Wait a minute.
Then it'd
2
be
minus 2 is
0 on the top.
0 on the top.
1 plus 1 times 0.
Oh, no.
2x. Does the 2x, Ryan?
What's,
See the 2x? So it's times 0.
Oh.
So that's
oh,
what
it's
they
times
cancel
0, not a
out.
1.
Oh, so that
Okay.
one gets
That's a
one.
lot of algebra.
So it's times 0. So
Yeah,
it's
this is
2x.
times 0. I was thinking it was plus 0.
Oh.
So we get negative
Thank you.
1/2 overall.
There's a 0 there.
So it's
It is times 0. I was thinking it was plus.
So now it's 2 over.
Okay, so it's
Four
negative
squared.
2 over
Negative
4,
2.
right? So that's negative 1/2.
Yes.
Yes. That's
Oh.
the gradient or something?
That is the
What are we
gradient
looking for?
at the point where the curve crosses y. So basically, when that's the slope of the point when it hits the y-axis.
Is it just 1/2? Wait, isn't it 1/2?
Sure, 1/2.
Oh, okay.
Is it negative 1/2?
Negative.
Okay.
Yeah.
Okay.
0 minus 2.
I know how to do the things. I just screw up the math.
You get the calculus part, you still can't do the algebra.
That's hit or miss.
Miss K.
Wait, what?
Miss K, is that you? Can't do the algebra.
Subtracting.
It's only adding and subtracting for her. She can do the multiplication just fine.
Yeah.
Or plugging in the right values.
Okay. So everyone good?
Yep.
We're gonna go to double I now.
Oh.
Is that no?
No, it's okay.
Okay. So
We
erase.
almost lost the camera, it's alright. Yeah, it's fine. So that's the gradient.
So it's gradient of the first one. Okay. Cubed plus 5xy plus y cubed equals 8. So now, can't we just do it down
Yeah.
each way, or do we have to do something with this?
I think that turns into 0. Cause
Yeah, it
you
turns
do
into
the-
0.
Yes, it doesn't matter. Okay, cool. Alright, so this becomes 6x squared plus, carry the 5. That disappears, right?
What?
No.
Becomes a 1.
Yeah.
Yeah.
And then, put that there, and then the y becomes 1 dy dx.
Whenever you took a derivative of y, you have to put dy dx.
Yes, exactly. But this is a dx over dx, which is a 1. So we ignore it. So there's just one of those plus
Yeah.
3y squared
dy dx.
dy dx
Yeah, we didn't get
equals
that.
0 because you derived that, right?
Yes.
Does that look good?
And the only time it would be different if there was a variable on that side.
Discrepancy?
In the in the packet, it has a there's like yeah, I don't know how it's
Yeah, I think he does it a different way.
no, but this is like her
Oh.
answer.
Oh, you have to do
Well, she has the same thing.
Yeah.
you have to do product rule for 5xy.
That's why.
It's the derivative of the
It's
first times the
product rule
second.
because it's two variables multiplied.
Yeah.
Okay.
Now we
I
have
was
to
like,
remember. That was way more similar.
I didn't even think of that because I
Similar
usually
than
think it's always an x. So I was like, it's not an x ln of x, and it's not an x e to the x. So you know.
So remember, implicit differentiation.
Okay, so that's
means
product,
there's probably
which
gonna
means
be-
carry that. So it's
X.
which one? It's
Isn't it just
addition,
x
so the
and
order
y?
doesn't matter. So it's keep the first,
derivative of the
derive the second, plus derive the first, and then keep the second, right?
Yeah.
It's that
Yes.
plus 3y squared dy dx equals 0. Okay, thank you. Okay, so now
We bring over
we
the-
try to, algebra it.
And then for 5x dy dx.
can distribute that. Plus 5y plus 8y squared dy dx equals 0. Okay, so we need to pull these two over here and get 5x dy dx plus 3y squared dy dx
Equals the stuff we moved over.
negative 6x squared minus 5y.
Then pull out the dy dx, divide by junk, and then
Yep.
you got dy dx.
Yes.
X, so 5x plus 3y squared here, and then equals negative 6x squared minus 5y, and then divide by that, and we end up getting, for dy,
And you have to plug in 0 for x.
Yeah.
we get,
My final answer was negative 5 over 3y.
alright then, so does this look good up to?
Yeah.
Alright,
Wait, no, it's squared. The 3y's.
what's squared?
You made it cubed.
3y cubed.
Oh, gotcha.
Squared.
Yeah, because it went down where we got. Okay, so we plug in 0, and then whatever we get for. So really, we should have solved for y, shouldn't we?
It's all for dy dx. We're finding the gradient.
Okay, yeah, but then what's y?
I guess you'll just have a y left over.
No.
Y is 0.
X?
No,
X is 0.
Y is.
We don't know what y is.
Couldn't you
Solve for
plug
y?
0 into the original and then...
Yeah, you're right. Plug 0 in here and get y.
Yeah.
Alright, so 0, 0. It's 2.
The cube root of 8
We
is
need
2.
to find the derivative, we need both x and a y, and we only know the x being 0.
Just, like, look at
So
it.
we plug it into the original, plug 0 in, cancels this out, y cubed equals 8. We know that's 2, because 2 cubed equals 8.
I was like low-key really creepy, not gonna lie.
Cube root.
Well, I was like, rid of that, cube. 2. That's the extent of my abilities.
It's like your
To wow.
pitch of your voice like changed drastically. So.
I thought it was like,
So now we just plug in both.
So now we plug in both 0 and 2 to have negative 6, 2 squared, minus 5 times 2 over 5, 0 plus 3, 2 squared, and that becomes negative 10 over
4 times 12. That's 4 times 2 is 12. Yep. Negative
that,
12.
so it's negative
10 over 4.
5 over 6. Is that what you said, Nick?
No, I mean, because I didn't do what you did where you found y. Is that what we were supposed to do?
Yeah, I think that's what I
We're trying
remember
to find
doing
a
that.
gradient. You should have
Yeah,
y's
we need
in
to
it.
we need to
It
find
needs to be a
this,
number.
So we need to
Yeah.
have both of the values.
Okay.
So that's how we do that. And it seems it has to be 2 because it can't be negative 2, so it's got to be. It's the
Yeah,
only
we
thing
have
it could be.
Well, it has to be a real number. It can't have y's and such in it because it's a gradient.
Yeah. Well, I mean, you could get it
Yeah,
out
that's
of
what
y's,
he
but then
got.
you would just need to plug the y in once you find it anyway. But yeah, you need to have.
Yeah, you should have variables in your gradient.
Okay, so can I?
Rule of
Yeah.
thumb.
Variables in my gradient, it's more likely than you think.
You're a walking meme. I hate you.
That's fair. Okay, so can I erase?
Yeah.
Yep.
We good? Alright. Okay. So what other problem do you guys want to do? You want to do a
number 6.
which number 6?
Go over number 3 on my calculator.
You finish 6.
Did we start six?
Which number 6?
Some of us started it. We had a study group that we started some.
There's a bunch of number 6s. Which one?
The one on the calculator.
I think 6 on the main calculus sheet.
I don't know why he didn't renumber because this is like which 6, which 5.
Together, so I- yeah.
I don't even know.
I know it's 11.
Miss Case makes sense.
Let's go over the chart.
He didn't actually.
Okay, so did you want to do that one? Oh yeah, that's the. What's that called? Integration by parts?
No.
Which one?
What's that one
It's
called?
the tabular.
Yeah.
7 has
Yeah,
tabular.
but you can't do tabular if there's an ln. It's the
Right. UV minus the integral of
Oh,
VDU.
yeah, 6.
Number 6 on,
Oh,
the,
number 6 was
on the
Yeah.
calculus one. That's when we have to do
Let's do that one.
And then number
that.
7 is
Yeah,
Tyler.
because only some of us reviewed that. So we'll do that for everyone. Okay. So basically, show that the integration from 2 to 4 of 4x ln x is going to end up being 56 ln of 2 minus 12. So get this to look like this to prove.
Would you like to see mine? I might speed things up. If you want.
I just did this one yesterday, so I think it's fresh in my head of how to do it. So, but if I screw up a thing, definitely use that to check me because that's very helpful. Huh? I think what? I know.
I think, therefore, I am.
Okay, so what we're gonna do is we need to integrate this. However, it's the multiplication thing. Normally, if it was deriving, it would be the product rule, right? Because it's multiplying. But we're integrating, so we have to do the reverse product rule, or it's this thing. UV minus integral of V du. I remember ultraviolet voodoo is how I remember the formula, but whatever works.
Is it UVDU?
It's UV minus the integral of V
It's the
du.
reverse product rule.
Basically,
So when you're multiplying two unlike terms in the integral, you have to do that.
I'll do that chart thing. Remember that we
Yeah.
came up with? Or we came up with at the study group, we figured out a way to look at a problem and then figure out if we have to derive it or integrate it, then we know exactly what method to use, and I'll draw that chart up here. Yeah, I think I remember how I drew the chart with the thing. Okay, yeah, we got that. So, integrate this, and it's going to look like this, which is nice. And I like how we don't have to solve for the ln, we can just leave it like that, which is nice.
Did they give you 4x?
Yeah.
Okay, so with this method, we need to do u.
Wrong way, and this way.
Yeah.
You're gonna find one of them's gonna be u, which you derive to find du. The other one's gonna be dv, which you're gonna integrate to find v.
Exactly. So there are these two different things here: 4x and ln of x. One of them you're going to have to derive. One of them you're going to have to integrate. The thing is, you can't integrate ln of x.
You have to
Right?
derive.
That one doesn't work. So that has to be a deriving thing. So you have to do ln x
It's
as
one
u.
over X.
So du is going to be 1 over x,
Yeah.
dx or whatever. dv is going to be the other term, 4x. And now you need to integrate that one. And when you integrate it, you get 2x squared because you add 1 to the exponent, bring it down to the bottom. So 1 goes to 2, put it underneath, and then divide it becomes 2x squared. So you integrate that one, and now you have this to make up this formula. So uv, so ln of x, and v, so it's 2x squared minus the integral of v du.
Which is 2x squared
2x squared
times 1 over x.
times 1 over x.
Now, if you got another ln in this, and like beside the integral, you have to do this all over again.
Yeah, sometimes it'll have to loop where the thing in here is something you can't integrate unless you use this method, so you have to keep doing it. This isn't one of
Sometimes
those.
there's a two-stepper.
Yeah, sometimes you got to do multiple. Remember that one that went forever, and then you had to just say some weird thing that Miss K did?
Yeah,
I can't remember
I
that,
don't
but it was
remember
cool.
what it was, but-
Anyhow, so this becomes
Yeah. So much fun.
x minus integral of, this becomes 2x because
Don't forget your A and
x
B.
cancels.
Don't forget
So
your
we
A
can.
and B.
What do you mean? Yeah, that's up here. We'll do that later. I don't know if you write it here.
You should.
Whatever. When I'm done, I'll do the line 2 and 4 to make you happy.
Okay.
Okay, so we have this. So 2x squared ln of x minus
X squared.
the integral of that, which is x
X
squared.
squared.
Thank you.
And we're assessing it from 4 to
2
2.
to 4.
Yep.
Block 2 to 4. Or 4 to 2.
2 to 4, but whatever. Okay, so that is the integral, and now we just need to prove that it's that by plugging in those numbers. So what we'll do is plug in 4 first. 2 times 4 squared ln of 4 minus 4 squared minus the entirety of 2
0.
2 squared.
Or 2, 2, yeah.
Yeah, this is 2. ln of 2 minus 2 squared.
Mhm.
So that, clean it up, looks like this. because this becomes 4 squared is 16, that is
32.
32
ln 4.
ln of 4
Minus 16.
minus
16.
I was just going to write 4 squared again. I was like, no, the step we're doing is cleaning that. This becomes 8. So I'm going to distribute this negative here, so this one's going to become a plus. So
8 ln 2.
ln of 2 plus 4. So now we have that. So the negative 16 and the 4 combine to be negative 12.
What we got?
And now these, what we need to do
You
is,
make it to a 2, right?
this means, this is the same as saying,
Which 2 got a 2, right?
ln of
And
2
we can
squared.
Bring that
Squared.
2 forward.
and you can do this
Yeah.
and bring it up
And
here,
it's 64.
and it becomes
64. Yep.
64 ln of 2 minus 8
ln
ln of 2, and that becomes
56.
56
ln 2.
ln of 2. Holy crap, I
Ooh,
can't write
Ryan.
this.
I'm writing in a different language
56
now.
ln of 2 minus 12, and that's that.
Yeah.
So that's how we do that.
And that was 5 points.
Did you say you, brother?
You not here.
You must want to see that.
Alright.
Can
I have
you
very bad
just do number 3 real quick?
Yeah.
I kind of forgot how to do that.
I just found out this eraser's
I
magnet.
didn't know what I just said right now.
That blew my mind. Okay, number 3.
I think it's an easy one. I just calculated.
Oh yeah, that's a synthetic division, but that's a
Yeah.
quick, easy one to go over, so that's a good idea.
Or you can use long division.
3 on the review sheet. Oh yeah, you can also use long
division
division.
if you really wanted to.
Could do both if you guys want to see it. Shall I erase?
Yes.
Yeah. Or if you,
They're good.
This one?
if anyone needs it, it's still there.
Okay. That was good.
Everybody go subscribe to Nick.
Like, comment, and subscribe. Alright. Find the quotient and remainder.
Yeah, we have, what did you do?
When this is divided by this. I'll just write it like that because. Alright, so quotient and remainder. So basically just divide it.
Yeah.
And the way you do that is this goes into this. So synthetic division you would do set this equal to 0. So because that's the factor. The factor is negative 2. It's x plus 2, but the factor is negative 2. You set
Hey,
equal
I
to
don't
0.
know how to do this.
This, you have to go through every.
Or is this an actual problem then?
Yes.
Yeah, it's
Yeah,
Number
you have to go through, when you're doing synthetic division, and well, any division of polynomials, you have to write the other terms. Because technically, that's what this is. You have to do all the powers less than that. So, 2, and then 0, and 0, right?
Yes.
So drop the 2. This becomes negative 4. Becomes negative 4. That becomes 8. 8. So we have 2x minus 4 with a remainder of 8 over,
The x plus 2.
is it x plus 2?
That's what I got, doing long
That's
division.
what I did,
And there you go.
yeah.
So that's how you do that. That's synthetic division 1. Just make sure
Wait,
you
why
put a
x plus 2?
0 as a placeholder.
Because
that was the,
Divide the remainder
the
by
factor.
the factor.
Like if you were doing 5 divided by 2, you would end up getting 2 plus 1 over 2. So you do the 1 remainder over this denominator.
Yeah.
So divide.
Okay, can you do
That was
long?
3
Can you
points.
do long?
Long division? Yeah.
That was 3 points, Brian.
Yeah, easy 2 points. Okay, so long division is x plus 2, the regular division part, 2x squared plus 0x plus 0. Okay, so for long division, you want to do how many times does x go into this? Or what do you need to multiply this by to get to this, right?
Yeah.
So it's 2x. Right? Everyone good? That's how you do it? So I can forget. So then you multiply it by this to get 4x squared. Or sorry, 4. No,
It's
4x, right?
It's 2x
You're right.
squared
You multiply-
plus 4x, and then you subtract.
Okay, thank you. I was like, wait, I know something goes there. Alright, so you multiply it, put it there, then there, and then you subtract it down, so negative 4x. This goes into that negative 4 times.
Add or subtract it.
Negative 4, so then you put negative 4x, bring it down to 0, and negative 4 times 2 is negative 8. Subtract it,
So it makes it positive.
so that becomes positive 8, and then that's your remainder, so it goes over this, so you do 8 over x plus 2, and there's long division. Well done.
So, on the last page, there's a number 1 at the bottom. It says use logarithms to solve the equation.
Yeah.
Can you do that one?
Not the extra credit. Was it?
It's
Yeah,
not
the
the
one
extra
before
credit.
that.
It's on the front side of that.
Oh,
Use
that.
ln both sides.
Yeah. I'm just really bad at it.
Yeah.
I understand the concept. I just
Alright,
don't
use
understand
logarithms to solve the equation 2 5x equals 3 2x plus 1. Okay, so, how do you do that?
Yeah, it's one question.
I don't know, I forget.
You want to see what I did?
Yeah.
Right there.
Let's do ln. Oh, gotcha. So you ln both sides.
When did he do this?
I think this was a Miss K thing.
Yeah,
Yeah.
now it's on this side.
Forever ago, yeah.
Alright, so you ln both sides, then because log properties, you can bring this over. That's how you do it. Thank you, Nick.
You're welcome.
Thank you.
1, okay, ln of 3. There we go.
What happened?
So what we did is we have to solve this, right? And because the x is an exponent, that's a weird one. So we have to ln both sides, because as long as we do it to both sides of an equation, we can do whatever the heck we want. So we
Alright.
ln both sides, so we just put an ln on there. And because of the properties of ln, you know how we take the exponents?
Okay, alright, I get it.
Pull it up there.
Power rule.
It's not.
Power rule. You know what? Whatever.
It's the power rule.
ln rule.
Do something.
Yeah, the ln power rule.
The natural log.
Okay,
You good?
got it.
You do? So next, solving for x, I'm gonna go with 5x. That, we can distribute that 2x, ln of 3 plus ln of 3, right?
Yep.
Do we want to do that?
I don't know.
I feel like we don't want to do that.
I feel like it's not going to help us any.
No, yeah, because that just makes it harder with the x.
How do you use the
Divide.
x?
Can
Yeah.
we just divide by
Sure, what number is this?
No, that works.
Wait, you can
You can
move over.
divide by-
Never mind. Yeah, wait, no, yeah. Can you like move the ln over or something like that? Like
It
divide
says,
it or...
Nick, what'd you do?
Give answer correct to 3 significant figures. So technically, we can just plug this all in, and then it's just all numbers, and it's way easier to solve for x.
Yeah.
Plug
Let's
what
cheat.
in?
That's not cheating. That's just
Okay,
fucking
you can
smarter.
ln of 2 and ln of 3.
Alright, so
So
yeah,
ln of
just
2.
figure out what those two things are.
0.6931
Alright, wait, hold on. F of x is what?
4.6931
6, 9, 3, 1,
5.
5.
Just so that we have to
Equals-
room for error.
Divide by
2x plus 1 of, what's ln of 3?
1.09612.
09612?
Yeah.
There we go. So now,
Oh wait, no what? Sorry. 0.98612. There's an 8 between the 9 and the 6. 1.0898.
0898.
No. Oh,
Not ruin my perception of this.
I'm going crazy. 1.098612.
1.0986. Okay.
You said you
1, 2.
1, 2.
1, 2.
1, 2, 3, 4.
We'll get
Right.
there.
Thank you.
That window's looking friendly. Okay. Okay, so now, someone with a calculator.
Not me apparently.
Can you
5 times that.
plug these in? Just, yeah, that times 5.
If Mr. Murmer was here, he probably knew how to
He'd
do
do
that
it.
in his head.
Like 0.3.4.
Yeah.
73!
Yeah.
Foolish mortals?
3.4.
3.46.
5,
5,
7.
7.
4.
4. X equals
2 times
2 times it, which is
2.19
2.19.
7
7,
2 2.
2, and then x plus
That.
1 point, because we distributed
And then we do
the 2x and then the 1.
minus that.
So we moved this, 3.4 thing minus 2.1.
1.26.
1.26,
8 5
8, 5,
1.
1.
That's good.
That's good. Thanks. There we go.
And then we divide
And then
Divide that junk over.
this
Divide this one by
by
this.
and it's 0.866.
This
Yeah.
one divided by this one.
No, the other way around. Because there's
No,
an
'cause
X on that side.
You're dividing both sides by this thing.
Yeah.
Yes.
Yeah,
So you're solving for
this
it.
divided by this.
Oh, yeah, okay.
Is that what you did?
Yeah.
Okay, so
What
it's
is it?
this.
0.866.
0.86606.
Can we do
Or,
like the simplification?
They did
one?
3 decimal places.
oh, so
Perfect. So
0.866.
0.83666.
Okay.
All right, cool. So,
Can I do the simplification one?
what do you mean?
Where's the
Like-
simplification?
No.
Not do the number thing?
I thought, yeah, I thought,
Allow. If you wanna, go ahead.
I can't do
I
it.
thought when they use logarithms in an answer, they don't want you to like find an actual logarithm.
It
But
said
it
give the
says
answer to 3
three
sig pigs. It literally told you to do this. Which is why I'm thinking I don't know how you would solve it otherwise.
I don't think you can.
No, because there's like 2 ln's that you can't get to be the same thing.
They're not compatible.
Not at all.
Yeah, so I'm gonna go with they kind of want
And
you
I
to
don't
do
think you
this.
can use them like common denominator with fractions. I don't think you can just like multiply.
There's some weird thing you can do, but who cares? We got the answer by plugging in the numbers because that's what it wanted. So I'm gonna go with this is good.
Did we ever do number 6 on that same page?
Number
No.
Because
I don't
I
think
have that one circled for some reason.
ln over x plus 1.
Yeah.
I think I started
I thought we
it,
might
so
have done that.
I would like to finish it.
Yep. We have time.
Thank you, time.
Number 6 on the
Number 6 in the same.
Yeah. What? Sorry.
No, were you saying something?
I just said why are we more productive when we don't have
the
a
last
teacher?
one.
You're
Yeah,
right.
that super extra whatever. It's on the front of that. It's the curve y.
Well, because he shows like the videos before we start doing the
I didn't
lecture.
talk to Mr. Anybody have
Because it takes
Mr.
away
Murmer's
time.
email?
Yeah.
Email?
I have Mr. Murmer's
Add him
email.
on
I
Last-
emailed it.
Last name dot first name at brevardschools.org.
He doesn't have a teacher email, he's not a teacher.
Yeah.
He is.
Did he ever get it?
I think
Yeah.
Does he have a
has
sub
one
email?
now.
I think it's M Murmer something. Because I have it on my phone.
No, he's on the
You just
global
need to
address
read
list.
it.
He
on
gave me a 9 out of
Facebook.
100.
Then you
9 out of 100.
A 9 out of 100.
Vicky
That's
Mena.
not good.
That's definitely
90
an F, and
something.
it brought my grade down to a 70.
wait on what?
It's
It'll be-
murmur.mark at
Some test it should
brevardschools.org.
have been 92.
37 in this class.
Okay, anyway,
Are you
Kurt.
serious?
We have
This-
exactly half of
Wait, over 37?
that. 37.
Oh my
Wow.
god.
Good job, Nick.
I fail every test.
Alright, the X
Since Mr.
coordinate.
Murmer got here, I have
That's
not passed the
It's
test.
mmurmer@hotmail.com if anybody wants it.
Hotmail.com.
Yeah, he has Hotmail.
All right.